Recording. All right. So today what we're going to do is we're going to go through a couple more theorems that are related to triangles. But we're like I already said, we're done with triangle congruence theorems. So these theorems that we're doing today are kind of just like extra little theorems that we can talk about when we're talking about triangles. There's not too many of them, but there are a lot of definitions today. There are a lot of definitions. So we're going to be writing a few times. I'm going to just set my timer and we're going to move as quickly as we can to write these down so we don't waste too much time. And just remember, if you missed one, you can either take a picture of the screen and come back to it later, or watch the video when I post it on YouTube later today. So can I have a volunteer read for us the definition of an interior angle?
An interior angle is an angle formed by two sides of a polygon with a common vertex. So a triangle has three interior angles.
Good. All right, go ahead and write this definition down. And also you can draw the little diagram to help you out when you're studying. It's always good to have diagrams. I'll give you guys about 1 minute. All right, about 30 more seconds. Like I said, if you don't finish, just make sure you take a picture of your screen. And you can come back to it later. All right. So this is interior angles. So this one's pretty easy. It's just anytime you have any type of polygon. So like, let's say I have a pentagon. How many interior angles does a pentagon have?
5.
5. Yeah. I think that was not a pentagon. There you go. Yeah, 5. So it's just the number.
Why did you say 6? It's a pentagon.
Yeah, pentagon is 5. Yeah. So interior angles are just simply how many angles are on the inside of a polygon. And then we have exterior. I have a volunteer read the definition for exterior angles. I know Tyrone.
An interior. I was reading what I was reading. An exterior angle is an angle formed by one side of a polygon, and the my camera is blocking it. And an extension of an adjacent angle. Adjacent side.
Good.
Interior angles form linear pairs with the interior angles.
All right, there's a lot to be said for this one. So first, for a second,
A bunch of gibberish today.
a lot of gibberish. So just start off by writing it down, but also look at the diagram, because the diagram explains it visually a little bit better. So the exterior angle is when you extend one of the sides of that polygon. So notice how they basically just made the bottom of that triangle longer. And then when they did that, it creates an exterior angle. Yeah, it's like an extra line of that triangle if you just keep it going. So that's my exterior angle. Ooh, Tyrone, very good. Yeah, I love that. So Tyrone pointed out that we've done this before when we're trying to see a transversal line cutting through some parallel lines. Sometimes I'll extend that line to make it more easy to see the parallel lines. So that definitely, we've done it before. Right, and it doesn't change the fact that it's a triangle. It's still a triangle. All we're doing is making that bottom side, we're just extending it. We're making it a little bit longer, which I didn't do very well. Making it a little bit longer, and then that creates the exterior angle. Okay. And then finally, we have remote interior angles. Can I have another volunteer read for us remote interior angles?
Me.
Go ahead.
A remote interior angle is an interior angle that is not adjacent to the exterior angle.
Right. So whenever you have an exterior angle, all the other angles would be remote. However, the one that's directly next to it, so this interior angle right here, the purple one, that would not be one of the remote interior angles, because remote is just the ones that are like out of the way. So go ahead, finish writing and copying down also the diagram. Make sure you copy it and label it. To answer Perla's question, adjacent just means next to. So whenever you see the word adjacent, that just means right next to. Next to. All right, go ahead, a minute more to copy down the definitions and the diagram. And make sure you label the diagram. Does anyone still need a minute to copy? All right. So with those definitions in mind, we have our first theorem. There's a lot on this page. You don't need to copy it all. For now, just let's look at just the theorem. So can I have a volunteer read for us the exterior angle theorem? Tyrone, go ahead.
The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles.
Good. All right. So just start copying down the theorem. Just the theorem. And then also copy down the diagram. Yeah, copy the triangle. All right, so now that we've copied it down, hopefully, let's read it. I'm gonna read it one more time, and then we're gonna see what exactly it's saying. So it's saying that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So which one is the exterior angle in this diagram? Which is the exterior
So
angle?
like 4.
4, good. So 4, that's my exterior. And which ones are my remote interior angles?
The 2, 1, and 3.
There's only, remember, remote is very specific. Can somebody else clarify which ones are the remote interior angles?
The remote interior angles. Oh, Emily already said them there.
Yeah, Emily typed it in the chat, but it's
Subtract my answer.
Oh wait, does that have to be equal to another one?
so let's
Wait.
read it again. The measure of an exterior angle is equal to the sum of the measures of the remote interior angles. So this is telling me that the measure of angle 4 is going to be equal to the measure of angle 1 plus the measure of angle 2. So basically 1 plus 2 will be 4. Any questions so far? Good. All right, so let's go ahead and now they give us a proof of this theorem. You do not need to write it all down, but let's just look through it and let's see if we can fill in the blanks. The question is like, why is this true? Why is this relationship true? So let's go ahead. Can I have a volunteer read? Actually, I'll start here because there's a blank right away. So it says by the blank, m1 plus m2 plus m3 equals 180. So which theorem tells me that 1, 2, and 3 is going to be 180?
The triangle sum theorem.
Good. Triangle sum theorem. Very good. So by the triangle sum theorem, we know that all the 3 interior angles, 1, 2, and 3, will equal 180. We also know that the measure of angle 3 plus the measure of angle 4, what's that going to be? 3 and 4. Angle 3 and angle 4. What will those add up to? Not 3 plus 4. Angle 3 and angle 4. Look at the diagram. Angle 3 and angle 4. What will those two angles add up to? Good, Janelle's 180. And how do we know that angle 3 plus angle 4 are going to measure 180? It kind of says it there, but can I have a volunteer read the rest of that sentence? Because what?
Yes.
Yeah. So,
Okay. By the substitution property of equality,
oh, not,
m.
sorry, not there. Sorry.
Oh.
So I'm finishing this statement. So far I said measure of angle 3 plus the measure of angle 4 equals 180. Now go, because. So from here, because.
Miss, sorry, is that the audio is like weird?
Oh, it's okay.
Like,
Can I read it then?
Okay, go ahead.
Because they are supplementary and make a straight angle.
Right, and remind me, what is a straight angle?
Like it equals 180.
Yeah, straight angle is just when you have a straight line. And we know that a straight line is 180 degrees. So since 3 and 4 are on a straight line, they are supplementary, they add up to 180 degrees.
Oh, I get it now.
Okay, so they have to add up to 180. Okay. Next line. Now we can go on to the next thing.
Miss, I have a question.
Yeah.
Why are only 3 and 4 equal to 180? Shouldn't like 1 be equal for like the straight angle?
Why are 3 and 4? Because when we talk about a straight angle, that means whatever the two angles have to be adjacent. They have to be next to each other.
Oh,
Four
okay.
are the only ones that are next to each other. So here, this whole thing is 180. But angle 1 is not a part of that. Angle 1 is off on the other side. Okay, good question. All right, so the next statement says, by the substitution property of equality, M, this is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, which are all, we already said, those are 180, is equal to, what other relationship is equal to 180? Yeah, 3 and 4. So measure of angle 3 plus the measure of angle 4. Oops, 4. All right. Subtracting the measure of angle 3 from each side of this equation, because notice there's a 3 on both sides. So I can take away measure of angle 3 from both sides. All that's left over is angle 1 plus angle 2 equals angle 4, which confirms our theorem. And this is why we know that the measure of an exterior angle is equal to the sum of the two remote interior angles. So basically, this is just kind of explaining why this theorem is true. Okay, so the measure of angle 4 is congruent or is equal to the sum of angles 1 and angle 2. Do I have any questions on this theorem and why it's true before we do some problems? All right, so let's see a problem. All right, so here I have some missing angle measurements, some variables. This means we know we're gonna have to do some algebra. So before I start plugging things in, who can tell me the equation that I can set up? So which angles are equal to which angles?
Miss, what did you say? Can you repeat that?
Yep, all I wanna do before I start plugging in values and writing down the variables and all of that, I just wanna know which angles, so I have a few. I have A, B, C, and D. Actually, D is not an angle, so we can ignore that. But which angles are going to be equal? So what kind of equation can I set up? Using what we know about exterior angles.
Wait, Miss, I have a question.
Okay.
What is the measure of that angle inside? Is C equal to 145 or like the measure inside?
We
of
don't
the
know the
triangle?
measure inside. We don't know the interior angle because that 145, what is that? Is that the interior angle or the exterior angle? What's this angle here? Is that an interior or is that an exterior?
Exterior.
Exterior. Which ones are my remote interior angles?
A and B.
A and B.
Ab.
Okay. So what's that? What does the theorem tell me again? What adds up? What's going to be equal?
145 equals B and A.
Right. So the interior angles, the remote interiors, are going to be equal to the exterior.
Miss, so this theorem helps us like basically find like the missing angle if we have any.
Yeah.
Because if we know that most of these together are 145, and then if we solve, let's say, and then we could just do 180 minus 145, and then get our answer for the last angle that's missing.
Yeah, exactly. So that's why this theorem is really useful because now there's a lot of things we don't know yet. We can use the theorem to find it out. Okay, so as just like Tyrone was saying, that A and B are going to equal the exterior angle. So A is 2Z. So I know 2Z plus 5Z minus 2 equals 145. All I did was I used my theorem to help me put together that equation. And now I can solve this equation and I can figure out the value of Z, and then I can go back because my final question is to figure out the measure of angle B. So all I know is this is my equation so far, so let's go ahead and solve for Z. So what do I do to solve for Z first?
You do 2z plus 5z, 7z. And then you add 2 to the other side. 7z equals 147. And then you do 147. Oh, wait.
Almost there. Okay, now what?
147 divided by 7.
Wait, she's trying to figure it out.
Okay, no worries. But what are we doing on both sides now?
Is it 147 divided by 7? Sorry, Paul.
What is 147 divided by 7? Anyone? 147 divided by 7? Good, Emily, 21. Am I done? Is that my answer? No, what do I still need to do? Good. All right, so I'm trying to figure out B, but all I know is Z right now, so I need to plug Z into the equation for B. I know B is 5 times Z, 5 times 21 minus 2. That's 21 times 5.
Or we don't have to plug it into the equation for B, because we could find out the angle for C by subtracting 180 for subtracting 145 from 180, and then plugging Z into A instead of plugging it into B. And then we can use that, add the angles, and use that to find out B. You don't have to plug it in.
That's a very good point, Daniel. Yeah, you can really do it both ways. It just depends
It's easier that way for me.
If that's easier for you, then do it that way. That's totally fine. This, for me, feels a little bit more direct because I don't have to go through and figure out all the other ones. Like I'm just going right into B to figure it out. So that works as well. So let's go ahead and just do this. So 5 times 21. What does that give me? 105. Good. So then 105 minus 2. I got 103. So yeah, it's just setting up those little equations and then using that information to figure out missing angles. Do I have any questions on this problem? Because we're about to do a very similar one and I want you guys to try that one on your own. All right. All right, so next one, on your own, go ahead and take about 4 minutes to work this one out. I want to know the measure of angle PRS. Once you have an answer, you can send it to me in the chat and I'll tell you if you got it right.
We're trying to find the missing angle, right?
Your end goal is to find the measure of angle PRS. So look carefully to see which one
I
is
didn't hear what you said, but I'm taking that as a yes.
Sorry about that, miss. It kicked me out.
okay.
What are we doing?
So you're working on this problem independently. Your goal is to find the measure of angle PRS.
All right.
Miss, do you have like the reactions feature?
You can use that, yeah.
You do?
Wait, what about?
And like, I'm gonna ask you a question. Can wait? I forgot what it was. Never mind. Oh, do you want us to send you the question in chat? And can you put a thumbs up if you want us to send it in chat? Because I can't hear you, and it's very loud.
So do you want us to find the perimeter or?
It's telling you what to look for. What is it telling you?
The angles for all of them?
No, read the instructions. The instructions tell you what to do.
Find MPRS.
All right, does anyone still need time? Because guys, it's been 6 minutes. This is unbelievably way too long. It should not take you 6 minutes. And I only got one answer in the chat so far. So what's going on? Okay, all right, I'll explain it all again. Let's do this. What does my theorem tell me? What's the theorem tell me?
R equals P plus Q.
Okay, so be a little more specific because R can mean two different things.
Wait.
3x minus 8
Mhm.
equals
X plus 2
Mhm.
plus.
Plus 90.
Yeah, plus
Oh
90.
yeah, because Q is a right angle.
Right, we know this is 90. Okay, there's my equation. Now I'm solving for x. 2 plus 90,
92.
92. So x 92.
subtract x, So I get 2x minus 8 equals 92.
Plus 8.
92 plus 8,
100,000 million
100,000 million divided by 2,
is
50.
50,000 million.
50,000 million. Okay, now I know that x is 50, but that's not what the question is asking. What's the question asking for?
The angle
The measure of P R.
PRS.
P, R,
So
so what
it would be it would be
It will be
142.
how'd you get 142?
Multiply 50 by 3, which is 150, and minus 8 is 142.
Good job. Nice job, Daniel.
1,000 million, 100,000 million, 100 million, 100,000.
All right, that's it. That's all we had to do. Do I have any questions? This should have been easy. I'm a little
100 million, 100,000.
why this.
I understand how to do it now. Thank you.
Yeah. Any other
Oh,
questions?
miss, we were just looking for X.
You were trying.
No, we were looking for R.
Miss, I found like I got
Yes.
142, not X, and then each
Verse.
individual. I thought that's what you asked for.
Perla, you gave me every answer except the answer I was looking for.
Oh wow.
No, but look,
We
if you
were
do
looking
90
for
plus
syrup.
52, that's what I did first. 90 plus 52 is 142. 180 minus 142 is 30.
Yeah, but if this was a test, you would have gotten it wrong.
Yeah,
You answered the
you're
question.
right. Because I can't hear you.
You got to read. All right. So that's that. Here's another definition. This one, from here on out, it's pretty easy. So we've got equilateral triangle and equiangular triangle. Can I have a volunteer read both of these?
An equilateral triangle is a triangle with 3 congruent sides. How do you say that?
Equiangular.
Equiangular triangle is a triangle with 3 congruent angles. If a triangle is equilateral, then it is equiangular.
Equiangular. Good. All right. So okay, remember how we talked about how A is fake? This is the one exception to A.
Oh my god, now this is just even more confusing.
But it's not, because the reason I can have this exception is because what type of triangle is this?
An equilateral triangle.
Equilateral triangle. So if all 3 angles are the same, how much is each angle going to measure? If all of them are the same, and we know they have to add up to what?
180.
180. So how much is each of these going to measure?
60.
So this is 60, this is 60, and this is 60.
On this one, it's the other one it's
Yeah, so this is triple A. So this is the only time where actually,
For these batteries.
the only time that this works is if,
so they all have to have the same angle.
right, it has to be completely
90, 90, 90, 90, 90, 90, 90, 90, 90.
Are we gonna do some proofs?
in a little bit, yes.
Yay.
All right, so if a
Why?
triangle is equilateral, then you know that it's equiangular and you can go both ways. So if the 3 sides are the same, then we know all 3 angles are the same. If the three angles are the same, then we know all three sides are the same. Okay, so we end up with an equilateral triangle, which is
Wait, so that's AAA and SSS, or
kind of put together.
oh,
You can put it all together. All right. Questions on equilateral triangles and what they are and what they look like. They're really easy. Just remember.
ASASASA.
Okay, go
Now,
ahead and make sure you write these down, these definitions and the theorem.
Be doo doo.
I'll give you about 2 minutes. Daniel, let me see you writing. You should be writing these 3 definitions.
I'm just gonna take a screenshot and paste it in a Word document.
Or that. I suppose that works. All right. Does anyone still need a minute to write down these 3 things? Okay. Can I have a volunteer read this problem now? Nice and loud.
Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. It is an equilateral triangle with the following dimensions in centimeters. What is the length of each side of the triangle?
What is the length of each side? What can I do to figure out the length of each side? Can anyone tell me an equation that I can set up?
4x plus 7 equals 6x minus 5.
Good, and how do
You
I,
could also do it the opposite way.
yeah, you can also do it the opposite way. You'll still get the same answer.
Okay. Okay, then you draw the line and then you minus 6x.
Mhm.
That cancels out. Minus 6x, that's 1. Wait, no, wrong thing. That would be
Negative 2x.
Good.
oh wow, Jalen, hi. Yeah, negative 2 plus that. And then would you add 7
Would I?
or
Subtract.
Subtract.
oh, subtract because it's already a plus. Oh, my bad.
You're good. Okay, what do I get there?
12.
Next.
Negative
Okay,
12.
thank you.
Good, Jalen. And now
Divide.
8.
Get
No,
yeah,
6.
6.
6 because it's already negative.
All right.
And
So,
then you plug it back in.
okay, good. X is 6. Now I plug it back in. So 4 times 6 plus 7. What does that give me? 4 times 6 is
24 plus 7, 31.
31. So each side is 31. Do I have units here?
Do you have what?
Are there units?
Yes, centimeters. So 31 centimeters.
Centimeters, good.
Okay, I got this. This is simple.
Yeah, this was really simple because as long as you know that all 3 sides are congruent, it's very, very easy to set up.
You only have to solve for one and then you got the entire triangle.
Right, all 3 of them are 31. All right. Daniel, you know we're on camera, right? You're being recorded. Okay.
Oh my God, Daniel.
All right, here's the last set of definitions. This one's a lot. There are a lot. So for this one, definitely make sure you copy down the diagram because that labels everything. Okay. So I want, let's see, there's 1, 2, 3, 4, 5 definitions. I want 5 volunteers. Do you think I can get 5 volunteers to read?
Yay.
5 volunteers.
Tyrone for number 1.
Okay, go ahead. Start with number 1.
An isosceles triangle is a triangle with at least 2 congruent sides.
Good. Isosceles, okay? Isosceles.
Isosceles.
Okay, an isosceles triangle. All right. Number 2, different volunteer.
Hello.
Go ahead, Janelis.
Can you hear me?
Yeah.
The concurrent sides are called the legs of the triangle.
We've got legs. Okay. Number 3.
Can I?
Go ahead.
The angle formed by the leg is the vertex angle.
Awesome. We have a vertex. Number 4.
Miss Lopez Reed.
No.
Sad. Daniel Reed. Carla. Somebody.
Raj, Alejandro, Emily. We got a lot of people.
Wait,
I
what
know
are we
this is-
doing? What are we doing?
Reading and
Oh,
taking the
like before.
definition.
You missed a lot. You're gonna have to watch the video again.
Okay.
This isn't reading class, but at least try.
All right, number 4. Who's going? Let's go.
Daniel.
Daniel, read number 4. Go ahead.
You're muted.
He's working on it. Go.
The side opposite the vertex angle the side opposite the vertex angle is the base.
Yes.
What is that grammar?
Daniel is missing his tonsils.
Oh, wow.
The side opposite the vertex angle is the base.
Yes. Is the base.
Sure, what is that?
Should be the side that's opposite of the vertex angle is the base.
Okay,
Yeah.
Jen. You tell the textbook how to do grammar. All right, and then the last one. Who can read or who can be the last volunteer?
Carla.
Angles that have the base as a side are the base angles.
Thank you.
Oh,
Angles.
All right, so we've got a lot to consider here. So go ahead and start copying down these definitions. I'm also going to redraw that diagram with a slightly bigger and more colorful way. So as you guys are writing, I'm going to just work on this real quick. Okay.
Wait, miss, I'm kind of confused with the legs. Like, the legs are the bottom. How come it's the top?
The legs are the two sides that are congruent to each other. Think about it like legs, like a person. Think about it.
I-
Where else have we seen legs in geometry?
Miss Lopez.
Yes.
Oh, I have to yell to hear me. Okay. So if the base is congruent to the legs, will it still be a base?
So if you have an equilateral triangle, then it just depends on the way that the triangle is rotated, whichever one's on the bottom.
Okay, thank you.
I understand.
Okay. So I tried to make that diagram a little bit more colorful, but those are the four parts of the isosceles triangle that you have to know. So make sure that you remember what each of these means. Any questions on them?
No.
Okay. So make sure, take a picture of the screen, okay? Take a screenshot, just have this ready to go in case you need it. I'm gonna go ahead and move on to the next slide though. So questions going once, going twice.
Wait, not yet.
Okay, I'll give you a couple more minutes, seconds. All right, can I move on now?
Yeah.
Okay. All right, so here's my theorem. Can I have a volunteer read the isosceles triangle theorem?
If two sides of a triangle are congruent, then the two angles opposite the sides are congruent. What is that English?
So here's another thing though. This theorem is more commonly known as the base angles theorem. So I know that it's called the isosceles triangle theorem, but I actually want you to write it down as the base angles theorem. The base angles theorem.
So instead of isosceles, you want base angles?
The base angles theorem. And what
Okay.
it says is basically that if the two sides are congruent, so if you have an isosceles triangle and the two sides are congruent, then the base angles will also be congruent.
Wait, congruent to each other or congruent to the measure of the sides?
To each other.
Each other.
So if BA is congruent to CA, if BA is congruent to CA, then angle, what is this, ABC will be congruent to angle ACB.
Wait, theorem or postulate? Oh wait, never mind.
Theorem. This is a theorem. Questions on the base angles theorem? We're going to do a couple problems now.
I'm waiting for the proof.
Ah, there it is.
Yay!
All right.
No!
All right, Daniel, come on. Let's do this. So let's read this proof. So it wants us to prove that angle B is congruent to angle C, and our given is what? Can that somebody read
M
that?
is the midpoint of BC, reason given.
So M is
Okay. Okay, so A, M, they're part of the same line. They're connected right in the middle.
Reflexive.
So that's one of them.
okay, but hold on. I know that's true, but let's wait till we get there.
Yeah, it's not split.
So Daniel,
Like,
I
that's
want Daniel, start thinking of those in your head. We'll share them in just a second. But for now, everybody go ahead and just copy down the table so that we can go ahead and copy down all of our steps. And it might be helpful, remember, to copy down the triangle so that you can start labeling it as we go. I'll give you guys about 30 more seconds to just copy down the table and the diagram. All right. Okay, so I have one given. However, there's actually one more given that they don't say it in words, but it's in our diagram. So can somebody tell me what else is given from the diagram?
M is the, wait, no, we already have that.
CA.
Good, I heard, good. So I know AC, was that Jalen? AC is congruent to
Yes.
BA. Okay, and that's also given.
And what Emily said. Oh wait, never mind.
Yeah.
Wait, is Emily right? I think Emily's right.
All right, so we know that so far. Now I can go ahead and start coming up with other things that I know based on this information. So I know Daniel said one thing. I heard a couple people say different things. So who would like to give me one more?
AM equals MA reflexive.
Okay, good.
I said that.
I know.
AM
You
equals,
stole it from me.
No, I didn't.
No, I said it first.
It doesn't matter. It was obvious. Chill.
You.
Wow.
BM
all right, reflexive. Good.
MC.
Good, Daniel. BM equals MC. How do I know that?
Because
because M is the midpoint, so they're an equal distance.
congruent.
Good. M is the midpoint, and
Ah,
then would be that this is
I
the
win.
Okay, chill.
definition of midpoint. All right. So now I know a few things. Now I know a few things. What can I go? Where can I go from here? Where can I go from here?
Can't we use the base angle theorem?
We're trying to prove the base angle theorem right now. So we can't
Oh.
use it as a reason.
Silly
That's what
fellow.
we're trying to prove.
Oh, then we can already prove it because the base angle theorem tells us that if like the two sides are congruent, then the angles are gonna be congruent.
Right. But we can't use it yet because we haven't proved that. We're trying to prove
Proofs are so complicated.
that. That's our goal. Our goal is to prove this statement. But how do I get to that? We're almost there.
Equilateral. No.
Okay, so Emily says AMB and AMC. Are you talking about the angles or the triangles? I just want to clarify.
Go on, Emily. Go on, Emily.
So when you say AMB equals AMC, are you talking about triangle AMB and triangle AMC, or just angle AMB and angle AMC?
I think she's trying to say that they're congruent. Something like that.
He's talking about the sides.
Never mind.
Sides. Okay. So, we know that what do I have between these two triangles? What do I know about these two triangles?
They're regular. Wait.
No. What I
They have
know,
a midpoint.
I have two triangles. Look at everything that I have labeled so far about these triangles. What can I say about the two triangles?
They're congruent
How do I know?
because,
Because of the SSS theorem?
Good. There you
oh
go.
my
Thinking of
God.
that.
So triangle AMB is congruent to triangle AMC because of SSS.
Good job, Perla.
And now what am I trying to prove? Go back to
The
the
base angle theorem.
go back to the original question. What is the question asking to prove?
Prove that angle B is congruent to angle C.
Good. I'm trying to prove that angle B is congruent to angle C. And now that I know the triangle is congruent,
You can use the base angle theorem.
oh, we cannot use the, I've said it 3 times, guys. We can't use the base angle theorem because that's the theorem that you're trying to prove.
CPCTC. Emily said it.
CPCTC.
Miss. I get confused with CPCTC. Because when I think it's CPCTC, it's not. But when I think it's not, it is.
Okay, let's quickly review this.
Congruent pyramids of congruent triangles are congruent.
If you know,
Congruent parts of
listen,
congruent triangles.
look carefully. If you know that the triangles are congruent to each other, if you know that they're congruent to each other,
That means the whole thing is congruent.
that means every little bit is congruent. So now let's say, like here, we were trying to prove that angle B is congruent to angle C, right? So if you know that the whole triangle is congruent, you use CPCTC to prove that one part of it is congruent to another part of it.
This is dumbest. If you know the whole triangle is congruent, then obviously all of the parts of the triangle are congruent.
Yeah, that is obvious. That's why CPCTC is kind of silly, but you still have to know it and you still have to use it.
This is so complicated, miss. This is why I don't like proofs.
Oh, you're fine.
You gotta try until you get it.
Now, do you want to also understand the converse of CPCTC?
No, yes.
So the converse is if you know that all parts of one are congruent to all the parts of the other, you can use the converse of CPCTC.
But if you obviously know that all the parts are equal to each other, then miss, this is dumb.
Yeah, I know.
So CPCTCC is one part congruent to one part. And converse of it is when you know automatically know all the parts are congruent.
Yeah.
So when I know that the triangle, all of the triangles are congruent, right?
Mhm.
And you ask, how do we know this and this is congruent? I want to say CPCTC.
Exactly. So just like in this problem, in step 1, 2, 3, 4, 5, in step
You also do
5,
SAS.
in step 5, I said, okay, the triangles are congruent. In step 6, I was able to say these specific parts of the triangle are congruent because of CPCTC. Because we didn't know that before. We didn't know that B was congruent to C before, but now we know. It was only because.
Could you also do SAS or no?
Well, now that you know B is equal to C, now I could use SAS, but I was not able to use SAS before because I didn't know that these were congruent yet.
Oh, okay.
Corresponding.
Yeah, those are corresponding, yes. Okay. Let's see how much time we got. We got time. Let me just pick a good problem for us. I put some really challenging ones, so I'm going to start with an easy one. Then we'll move on to harder and harder. But we'll do these all together. So base angles theorem. Based on the base angles theorem, which two angles of this triangle are going to be congruent?
Wait, can you repeat that?
Using the base angles theorem, Which of these two angles will be congruent?
D and F.
Not D and F. Look
Wait.
carefully.
E and E?
D and E, yes. Because remember, within this isosceles triangle, these are my legs. The legs are the ones that are congruent. And the base angles are these, right here. So this triangle over here is not in the right orientation. Okay, so you kind of got to twist your head around a little bit, because my base angles are D and E, since the sides that are congruent are DF and EF. Okay, so you kind of have to like visualize it sideways. So I know, what do I know about all of the angles in this triangle?
Wait. What did you say?
What relationships do I know about the angles inside of this triangle?
Wait,
They're
if we figure
congruent.
out the angle of D, we can figure out the angle of E.
If we know the angle D, we could figure out angle E. Why is that?
They're congruent, right?
Yeah. So if D is 4x plus 1, E also has to be 4x plus 1. They're equal. But now I need to solve for x. So what other relationship do I know about triangles and the angles inside?
Wait, what?
What else do I know about triangles and all of the interior angles?
That they're congruent?
Oh, are they?
Wait, no. They have 3 interior angles.
There's 3 interior. Dig deeper. What else do I know?
They also have 2 remote interior angles.
Okay, that doesn't help me. Guys, think about what will help me. I'm trying to solve for x. What do I need to do?
Set up an equation.
Set up an equation. So what type of equation?
4x plus 1 equals 5x minus 4.
But those are not equal, Tyrone. We already went over that. Those are not equal to each other.
Four x plus 1 equals 4x plus 1.
4x plus 1 equals 4x plus 1. What happens if I try to solve that? What's going to happen if I try that?
You're going to get an infinite.
Again, that's not gonna work out.
That's not going to work out, because if I actually tried to solve it,
Oof.
I would just end up with
Well, I tried.
0 equals 0. So that's not going to help me out. What else can I do?
Maybe do 5x minus 4. Wait, no,
Mario's cracking up like.
something that equals 180, because all 3 of them together are equal to 180.
Oh, there it is. All 3 of them have to equal 180, don't they?
So
Add all of them up.
5x minus 4 has to equal 60.
No, not necessarily, because we don't know that they're all equal to each other. All I know is that all 3 of them have to add up to 180. So go keep going.
454, 62.
What do I write?
60.
5x minus 4.
Um,
5x minus 4 equals 180. This whole angle is going to be 180.
Ms. Lopez,
plus 4 plus 4 X plus 1 equals 180.
Okay. And Emily actually gave it to us a little bit more simple because since I have 4x plus 1 and 4x plus 1 twice, you could also say 5x minus 4 plus 2 times
X is either 11 or 12.
equals 180. I don't want to know what x might be. I want to know what x is. I'm not going to guess. I'm going to figure it out using algebra, Daniel. Go ahead and solve this equation. Let's go.
Deeper. Oh man.
What do you get for x?
12, 12.
It's not 12. It's 14. Good job, Emily. 14.
Math, I got 12.
Nope, it's not
Have to
12.
distribute
I
first.
told you it's not 12. When I distribute, I get 8x plus 2. Combining like terms, I get 13x minus 2. I add 2, I get 13x equals 182. I divide by 13,
14.
x equals 14. Am I done?
Plug it back in.
Plug it back in. Which angle am I trying to find?
E.
E. Plug it in. 4 times 14.
56.
Plus 1.
57.
7.
Let me write this down.
Now you want to write it down? We're moving on to the next problem.
Oh,
You want to write it down? Write it down when I'm writing it.
I got it.
We don't have time for this, but this is my goal for today, guys. I wanted to be able to do this problem, but we're pretty much out of time, so we're not going to get to it. If you feel like it, you can take a screenshot and try it out on your own. So take a couple seconds if you would like to.
Like you said, take the screenshot and try it out on your own.
Yeah, at a later time, because right now we got to wrap up and go.
All right.
All right, so here we go now. As a reminder, you guys have homework due tonight at midnight. If you haven't done it yet, you got to do it tonight. Otherwise, I'm not accepting it. So make sure you guys are setting reminders for yourself. Make sure, check to just make sure you did it. Because sometimes, I don't know, maybe you thought you did it and then it turns out you did not. Do I have any final questions before we go?
Thank you for teaching me.
You're very welcome. All right. You guys are free to go. Your homework. I'll see you guys tomorrow. We're going to be doing algebra review. So just so you know, tomorrow we're going to do a EOC review. And then on Friday, we'll have another geometry lesson.
Okay.
Okay. Bye, everyone.